Hey, what's going on, guys? Back here with another video. You might have noticed I haven't uploaded in quite a while, even though it's summertime now. I apologize for that. I was on vacation, um, so I will be back for basically the rest of the summer. So hopefully I can get more videos out, especially on this series. Yeah. So as you can tell, I made this video to part two of this series about me building the shifter. Yeah, so I'll go over all the rework. You can probably tell a lot of it's different from what I showed from the last video from a while ago. Um, I was on vacation. I was working on it, but I didn't. I decided to wait until I got back to record. Yeah, so I just got back yesterday, so I'll start making videos about this again. All right. So you can tell. First thing I'll talk about is the new shifter design. So basically, you can see it's canted now. It's a lot shorter. The reason for that is that I wanted to make it shorter because the desk I'm mounting it on is already very high, and I've realized that with the length that it was in the previous video that you saw with the old version, yeah, it was just gonna be way too long. I'd be reaching like basically over my head to reach it. So I shrank that down, and then I put it at this angle because I kind of wanted to reach towards me a bit more, um, rather than reaching like on top of my table. And also what I did is you can see I added the clamp here. It's actually originally I was planning for it to sit on top of my desk, but actually I realized I could get even more. I could put it even lower if I just mounted it below my desk. So you see this clamp here on top. Here I have I use I forget which feature script it was that I added. Yeah, thread creator. I installed that feature script. These are, I forget what thread size. Yeah, these are M25. And then this one, the hole here is M25.2. Yeah, so you see I threaded a hole in the clamp, and then basically this is kind of the handle on top where you could tighten the clamp. For how to when you assemble it, what you do is you wouldn't worry about this because this part is printed separately. This base, this screws onto the bottom. Basically, what you do is you take the large screw, you screw through the hole, and you screw the clamp part on the bottom, and then you just put it against. You just put the table between the bottom here. Bottom table sits between these two parts, and the top edge would just be clamped down by the bottom of the clamp. Yeah, so that's about that for the clamp and new lever design. And also I made sure that there's enough space here so that when you upshifted it wouldn't hit the front of the table. I'll hide this here. So yeah, so you can see the new internal side. The part I worked on mainly was this new part. This part I know it looks kind of weird. Basically, it's how you actually give tension to the cog we talked about before. So you have the divots in it, and then every time you lift, the spring makes it so you kind of like push it into the next position. So here we have this plunger part. You can see it kind of sits inside there, and it's gonna slide. And we have a spring that I forget the dimensions of it. I have it in McMaster-Carr that I'm gonna order. But basically, that's gonna sit in here, and then. But notice these holes. Basically, these holes are where you could just stick a screw with a through bolt, and that's basically what the back of the screw, or the spring is going to sit against. So that's like what the spring is going to be pushed against when it's pushed by the plunger. And then the different holes basically just give you 4 different amounts of tension to put. So if you want like more force, if you want to pull with more force to shift, then you can put it in the furthest forward hole, and if you want the least force, you put it in here. This is the cog spring, so it's about yeah, just look like that. That's what's gonna sit in. I'm ordering that on McMaster-Carr. Here's the spring I'm ordering. You can see all the details here. Main thing was these two parts of max load in pounds and the spring rate. Obviously, it depends how much is being compressed. Based on the 4 different levels of starting compression that we have from the different places you can put the screws, the least amount of compression is basically like this is basically uncompressed when the cog is being pulled. So yeah. Anyways, yeah. So yeah, it's also it's basically finished now. So basically all the CAD I have you see now is finalized. Here you can see in the assembly. That was pretty cool. You can never mind. You can rotate this cog, and you can see I have a tangent constraint. You can see the plunger moving up and down with the cog. You can apply a tangent constraint with the claw and have it touch here, but the thing is when it does it, it's like it takes a really long time for it to calculate geometry, so it's just like really laggy when I do that, especially since Onshape is clan based. So I don't really simulate that, but that's fine. You can simulate them independently. Yeah, so anyway, you're probably wondering, because before I hadn't really sorted out how I wanted this to connect to the device I'm using. I have an Xbox Series S is what I'm connecting it to. Basically what I found out, because what I originally was planning on doing was buying a Raspberry, I think it's a Raspberry Pi Pico. I'm not exactly sure what I was originally planning to use as the microcontroller, but basically what that was going to do is I was going to run code using this thing called X input, which can basically make the USB device re-recognize as a controller, or yeah, as a controller. But the thing is, that doesn't work with Xbox. For the Xbox, you have to have an actual licensed controller because the software has built-in identifications, because you can't use like a thing that doesn't actually identify as a real Xbox controller, and you can't use X input for that. So what I'm doing now is I found a controller that is like broken on eBay. Like it still works, but like one of the triggers is missing that someone is selling, so I can buy an Xbox controller for really cheap. And then what I'm doing is I'm going to take out the PCB from the Xbox, and I can wire two limit switches, which you can see if I go to the assembly. Basically, the mounts for them are. Let's hide, please. Hide. There we go. Okay, so yeah, so this is where the limit switches would mount. And basically, you have one for upshift. This is the upshift limit switch. So the downshift limit switch is there. You can see this is an Omron D2F series. This is basically, it's not even an official CAD, but this is just someone I found that is just the CAD for it, so I can reference dimensions off of here. Yeah, so that's, here you can see the switch. Basically, it's going to be mounted so these two holes stick, or the two mount pieces right here go into those two mounting holes, and the switch would stick at the bottom, and they'll be clicked when you upshift or downshift, because they'll get hit by the lever. And then those are going to be soldered directly to buttons on the PCB board. Not really sure how I want to mount that. It's not really that important. I'll probably just start with making like a 3D printed case, and then I could really just screw that onto here, or like, you know, any of these holes. It's not that important. But yeah, so that's how the Xbox is gonna read upshifts and downshifts. Yeah, so I haven't ordered all the parts yet. I can probably start with printing this very soon. But yeah, once I order the parts, I'll make an assembly video. I might actually do a face reveal in that video. You can see my face. I don't really know if you'll care or not, because it's not a very big channel, but I'll probably just show my face in the video anyway. So yeah. Yeah, hope you guys like the rework, and I'm excited to get building with this, or get this built, and maybe hopefully very soon we'll be able to start using it, depending on how long everything takes to arrive here. Yeah, see ya.